The 3D coordinate system and transformations is one of the first things you need to understand when you start learning about React 3 Fiber or really any 3D rendering engine, whether it be like an offline render in Blender or a game engine or whatever. You're always going to need to position objects within the 3D space. And the way you do that is by applying transforms to objects. Now, what we're looking at here is just a little helper guide for what the 3D space looks like within React 3 Fiber. So this is the coordinate system. There's 3 axes. There is a Y axis, the Z axis, and the X axis. And those 3 are going to provide us with everything we need to move stuff around. Now you'll notice that the Z-axis comes towards you, and that's a little different if you've used like Blender or Maya or something. A lot of times the Z-axis is like up and down, but this is how it is in WebGL. And you'll also notice that the cube we have in our scene is positioned right in the center at 0, 0, 0. And 0, 0, 0 corresponds to an X value of 0, a Y value of 0, and a Z value of 0. You'll also notice that the cube component is being provided these position coordinates via a prop. And in React 3 Fiber, that's how you apply transforms. You set a prop on the object. Any object in a React 3 Fiber scene generally will accept these props as long as it's some sort of geometry object. Like textures don't have that prop, and neither do materials. But if it's something that's being positioned, you can set a position, a rotation, and a scale. And anytime you set any of those 3 props, you always set it by providing an array with 3 values: a value for X, a value for Y, and a value for Z. You'll notice even my lights have positions, and my cube also has positions. Although in the case of the cube, those values are being provided by some state variables that are attached to these inputs in the control panel. This is going to help us explore how to apply transformations. Now you'll notice that I just set the X, Y, and Z position to 2, 2, 2. And right away, my cube moved out into a new quadrant away from the 0, 0, 0 position. That's how the position works. It'll just, within global space, move to that spot. Rotation also has an X, Y, and Z value, but it will work with radians. And radians are essentially ratios of pi. 0.5 pi is equivalent to 90 degrees. So you'll notice that 0.5 pi is 90, 1 pi 180, 2 pi is a full 360 degree rotation. I can explore that by trying to increase this Y value slowly. And as I rotate, the cube will slowly rotate until you get to 0.5. And now it kind of looks like it's back in the same place, but that's because it's rotated exactly 90 degrees. If I keep going and I get to 1, it's now rotated 180, etc. And you'll notice that as I rotate the Y value, that what it means to rotate around the Y-axis is to kind of spin as if the Y-axis was sticking directly through the cube. And it spins around that axis. Maybe it'll be a little more obvious if I put it back to 0, 0, 0. And then it looks as if the Y-axis was a spoke and the cube is just spinning around that. If I put some X rotation on, it spins around that X axis. So that's the rotation transform. Now let's look at the scale transform. Let's put our cube back out in some empty space so it's a little easier to see and try applying some scaling. So if we add an X scale factor, it's now basically a multiplier. So whatever the natural size of the geometry is, the scaling will multiply that. So 2x is now 2 times as long. Now 2x and y. And then if we apply 2, 2, 2 to all three values, we will have a cube that's just 2 times as big. Same thing works in reverse. So we can make it half the size by doing 0.5, 0.5, 0.5. And that will just shrink our cube. Now, that was cool, but there's one more tricky thing to know. So all of these transformations we just did were within the global space, and this grid is essentially representing the global space. But in a React 3 fiber scene, the scene itself is it's a tree of nodes. And at the top is the global space. In React 3 fiber, that's represented by the canvas. But then within objects, you can have nested things. Like you could have a light nested under a group, and you could have some geometry also nested under that group. You can nest things pretty much as far as you want to. So let's dive a little deeper into looking at this cube component. The cube component is not just cube geometry in this case. There's actually a group node at the top. And a group is something that you can transform, but it doesn't really have its own mesh or geometry to it. It's kind of like a container. It can hold multiple things. We could actually have another box under here. And that box could also have its own transforms. So we could apply a different transform value. And now there is another box. So if you look at what I put in there for the vector position, 2, 2, 2 is no longer the same place as the first box. So why is that? If you notice, it's kind of additive. So this 2, 2, 2 is kind of putting the box now at 4, 4, 4 in the global space. Well, the reason for that is that every time you add a new object to the scene, it gets its own coordinate system. And we can visualize that by adding another grid to our group. And now you'll notice, okay, look, this grid is positioned kind of at 2, 2, 2. So it's inheriting the position of its parent. And then any additional transforms you set underneath that parent on the children of the parent, they are within this new coordinate system that was created. And you could have as many of these as you want. You could put another group inside of this original group, and you could move that around. Let's do something crazy and put this at -5, -5, -5. And there's nothing in here yet, but let's move our grid inside of that group. So now the grid is all the way down here. And we could actually keep both of these to see that every time we set a new transform in a new node, we get this nested tree of coordinate systems. And that's handy because it lets you position things within a component. So in this cube, we could kind of build up a shape, within this group, we could build up a shape where we kind of compose together boxes and maybe make some kind of like a little set of boxes. And now, if we want to kind of move that around, it's easy. We can just move the parent group and it will move everything all together. And in addition to the position, we can also show off how the rotation now is global. If I rotate this group, it will rotate everything that's inside of it. And it rotates around the center point. So that's an introduction to the coordinate system. I know it's pretty basic, but I recommend playing around with it just to get your feel, because this is the bread and butter stuff for any 3D scene. No matter what you're building, you'll be positioning things. So go ahead and play around with this sandbox. I'll put it in the in the description. And I look forward to hearing all your feedback. Thanks. Bye.